Welcome to Maths Minders Academy, your go-to channel for mastering maths concepts with ease. I am Mr. Ogechi, and today we are diving into part 2 of our series on solving the IGCSE Mathematics Paper 4.1. In part 1 of this video series, we covered questions number 1 to number 4, providing step-by-step solutions to guide you through the process. If you haven't seen that video yet, be sure to check it out on my channel. I'm going to drop the video link on this video description. In this video, we are going to be tackling the remaining questions, explaining key concepts, and showing you the best method for solving these types of problems that very often occurs in IGCSE mathematics. So grab your calculator, pen and paper, and let's get started. And don't forget to like, subscribe, and hit the notification bell so you never miss out on new math tips and examination solution here on Maths Minders Academy. Let's move on now to the question. Question number 5. 5A, we are told that P is the point 1,7 and Q is the point 5,5. And so here we have to find vector PQ. We have to find vector PQ. So I'm going to use something that will help us to get this. So we look at this vector from P down to Q. Okay? So let's put an arrow here. So we can have vector OP, which is a position vector, and we can have vector OQ, which is a position vector, right? So we have a full triangle. Now, you agree with me that a movement from P to Q, all right, is the same thing, can be accomplished if I go this way, PO, and then I proceed from O to Q, all right? Remember, my mission is to start from O and end my journey on Q, but I can go from P to O and then from O to Q. But you will notice that going from P to O is going against the direction of the arrow that is pointing O to P. So that is negative here. I'm going against that arrow. So this is minus OP, so that I can get a position vector, then plus OQ, all right? Okay, now we can write this. We can turn this coordinate to position vector, and it's going to give us 1, 7, okay? That is OP. And we can also turn this to position vector, that is the coordinate Q to position vector. It becomes 5 and minus 5, okay? This is OQ. So this becomes minus OP is this vector here. This is OP. This is OQ, okay? So this is going to give me 1, 7 plus, this is going to give me 5 minus 5, okay? So this is going to give me minus 1 minus 7 plus 5 minus 5, okay? If we add this together, we are going to get minus 1 plus 5, and this is minus 7 minus 5. And this gives us minus 1 plus 5 is 4, and minus 7 minus 5 is minus 12. So the vector we are looking for, that's PQ, is 4 for the horizontal component, and for the vertical component, we have minus 12. Now, here we want to show that the magnitude of vector OP and the magnitude of vector OQ are the same. All right, now the magnitude means size. When we talk about magnitude, we are talking about the size of the vector, okay? And generally speaking, the magnitude, if vector AB is given as x, y, take note, then the magnitude of vector AB is the square root of x squared plus y squared. So you square their components. Okay, so here, the magnitude of vector OP will be square root of, remember this is vector OP here. Okay, so we are going to have minus 1 squared plus minus 7 squared, okay? This is going to give us 1 plus 49, and that gives us root 50, okay? Now, the magnitude of vector OQ will give us square root of, look at vector OQ here. This is vector OQ here. This vector OQ. So we have 5 squared plus, put in bracket, minus 5 all squared. That will give us 25, root 25 plus 25. And that gives us root 50. So we've seen, therefore, that vector OP, the magnitude of vector OP is the same as the magnitude of vector OQ. Okay? That's what we want to show here. Now, the third part of this question says that PQ is a chord of a circle with center O. So we are asked to calculate the circumference of that circle. So now, you know, if you are to find the circumference of a circle, the circumference of a circle is determined by this formula here. So we need the radius. But if we go back to the vector, if we go back to PQ, if we go back to PQ, okay, it's going to, if you look at what is mentioned here, we are told that PQ is a chord of a circle with center O. That means if the center of the circle whose chord is PQ is O, that means OP and OQ are the radii of that circle. So we can actually get the radius of the circle. So radius of the circle, radius of this circle will be the magnitude of the vector OP. Okay, that will be the radius. And the magnitude is root 50. So circumference, which is what we are looking for, is 2 times the pi is 3.142, or you can make use of your calculator value for pi, then times root 50 here. Okay, and then if we multiply out with our calculator, this is going to give us 44.4345, 4345, and so on and so forth. So being that this number is not exact, because we have also introduced pi, which is in itself a rational number, which is not exact, we are going to round up this number to 3 significant figures, and it gives us 44.4. So this will be the circumference of the circle. So we write here 44.4. Now we move on. Ivy tells us that PQ is the diameter of a different circle with center R. Find the coordinate of R. So now, if we go back to the diagram here, if PQ is the diameter and the center is R, okay? Remember that the diameter divides the circle into two halves, okay? Two semicircles. So we are going to get R if this is the diameter now. We have P, we have Q, okay? And remember that P has coordinates. Let's look at the coordinate of P. The coordinate of P is 1,7. Coordinate of P, 5, minus 5. So this is 1,7. This is 5, minus 5. So R is the center. That's the middle of the diameter, okay? Now, to get this R, that is going to be the midpoint of this line segment. So it's going to be 1 plus 5. The S value of this R is 1 plus 5. You add the S value of P and the S value of Q and divide by 2. You take the Y value here, which is 7, add it to the Y value here, which is minus 5, and divide by 2, okay? That means R, we have these coordinates. 1 plus 5 is 6. 6 over 2 is 3. 7 minus 5 is 2. 2 over 2 is 1. So R, we have this, okay? So we have seen the coordinate. We are asked to find the coordinate of R. So we write 3 here and we write 1 here. Okay, so we've seen that. Now let's move on. The V part of that question number 5 says, find the equation of the perpendicular bisector of PQ. Give your answer in this format, okay? Now, for the perpendicular bisector, remember that if a line is going to bisect the line segment PQ, the gradient, the slope of that line, the product of the slope of that line and line PQ will give us minus 1. So if we say let M1 equals slope of PQ and M2 becomes slope of a line perpendicular to PQ, then the product of this gradient, this slope, will give us minus 1, okay? That's the condition. Now, we can get M1, that is Y2 minus Y1, or rise over run, okay? X2 minus X1, okay? So when we look at P, don't forget this is the coordinate of P, and this is the coordinate of Q. So this is our X1, this is our X2, this is our Y1, and this will be our Y2 here, okay? So with that, we can now put in minus 5, minus 7, all over S2 is 5, S1 is 1. So this will give us minus 12 all over 4. That gives us minus 3, okay? So we have minus 3. Now, that means if we multiply, now if we say minus 3, which is the slope of the line segment PQ, multiplied by the slope of the perpendicular line, okay? We multiply by the slope of the perpendicular line, so we are going to have here to be minus 1. This slope will be minus 1. So M2 is going to be minus 1 all over minus 3. So this perpendicular line will become, the slope will become 1 over 3. All right. So the equation we are looking for is now going to be y. So this slope here is 1 over 3x plus c. But because it's a bisector also, is actually dividing PQ into 2 equal parts, meaning that it's going to pass through R, which is 3, 1. It's going to pass through R. So we have a line. This is P, this is Q, and then this is that perpendicular bisector. It's going to pass through the midpoint, dividing this into 2 equal parts. So the value of S here is 3. The value of Y here is 1. So we put 1 here for Y, and we are going to put 3 for S. So we determine what our C is. So we have 1 equals, when you multiply out here, you have 1 plus C. So here, C is going to be 1 minus 1, which is 0. The equation we are looking for becomes 1 all over 3x plus 0. So Y equals 1 all over 3x, okay? So here we'll enter it 1 all over 3x. So that gives answer to that question. So we go to 5b now. Here, for 5b, we are told that the position vector of A is small letter A, and the position vector of B is small letter b. M is a point on AB such that AM ratio MB is 2:3. Find in terms of A and B, which are the components of vector AB, the position vector M, and give your answer in its simplest form. Now, we know from what is given, the position vector of A is written as OA and is vector A. And the position vector of B, which is OB, is B, okay? So here, AB, if we want to find vector AB, it's going to be OB minus OA. Okay, I hope we understand this using the triangle law. If this is, let's say this is AB, okay, and this is O, okay? So this is OA, this is OB here, okay? Now, look at this, follow the arrow, OA plus AB, okay? This OB closes this diagram, equals to OB, okay? If you make AB the subject, okay, it gives us OB minus OA, okay? So that's how I got this. Now, here, OB is B, and OA is A, okay? Now, we now want to divide this vector AB using this ratio, okay? That means AM, vector AM, all right, is actually going to be, the sum of this ratio is if you take sum of ratio equals 2 plus 3, that is 5. So this is going to be 2 over 5. AM is 2 over 5 of AB, okay? Because it is AB that is divided into this ratio, okay? So it's 2 over 5 AB, which is, okay, let's say 2 over 5 AB, okay, which is 2 over 5. AB is B minus A, right? Okay, so remember what we are looking for is the position vector of M. That means we are looking for OM. Take note, this is the position vector of M. This is not known. That's what we are looking for, okay? So now we have AM. Now, if you look at OM, if we look at OM, let's say if M, let's fix here, let's say if M is here, and I'm looking for, I want to come this way. Okay. Now, if you look at this, you will discover, you agree with me here, that OM, if we say OA, vector OA plus vector AM is equals to vector OM. So I want to move from O to M. So I can move from O to A and then from A to M. Remember, this arrow goes this way. So if you make, since we are looking for OM, we've seen what OM is. So OM that we are looking for is OA, which is vector A, plus AM, which is 2/5B minus A. Okay, 2/5B minus A. So this gives us A plus, we open the bracket, 2/5B. We use 2/5 to multiply minus A, and it gives us minus 2/5A. So when you wrap it up, A minus 2/5A, that is like saying 1 minus 2/5. That will give us, if you do this LCM here, this will be 5 minus 2, that's 3/5, okay? 3/5. So this gives us 3/5A, then plus 2/5B, all right? So that will be the answer there. So we write here 3/5A plus 2/5B. So that is vector OM. We write OM equals this. So that's the position vector of M. We will have a short break now. We'll be back very soon. Yeah, welcome back. This is Math Minders Academy, your go-to channel for mastering math concept with ease. My name is Ogechi, and today we are doing a tutorial video on part 2 of our Paper 4-1 IGCSE 2024 examination series. If you are new in our channel and you have not subscribed, we urge you to go ahead and subscribe so that you continue to enjoy wonderful tutorial videos from our channel. Hit the notification bell so that you will never miss out on any new math tips and examination solution here on Math Minders Academy. Let's proceed to the next question. Question number 6. All right, here we have this diagram. I said the diagram shows the positions of two lighthouses, A and B, a boat C, and a harbor H. So we can see all this. We can see the lighthouse A and B. This is the lighthouse here. This is another one here. This is the lighthouse B. Okay, we can see that. And we can see the harbor here. Okay. So, and we are told that C is due east of B. So meaning that there is 90 degrees here, okay? Since D C is due east of B. All right. So we want to find the bearing of the harbor from both C. From this both C. So I want to put a line here. So what I want to do here is, what angle will I turn like this to get to this line that will bring me to the harbor from point C, or from both C all the way to the harbor? I am going to turn around and make a particular angle. That is what we are looking for. Now remember that this is also 90, all right? Because this is North Pole, and this is due east. This line here is due east. Okay, so we have this. There are co-interior angles, okay, between two parallel lines. When you have a parallel line, another parallel line, if this is parallel to this, okay, you have a line that if this is 90 here, definitely this is going to be 90 here, because the two lines are parallel. Okay, so now all I need to find is, I know that from here, okay, let me make a blue mark. This, from this point to this point, is 180 angle on a straight line. This is 180 degrees. So I only need to find out what is the size of the angle here. What is the size of the angle here? All right. Now, it's very easy to find. This is 25. So 90 minus 25 degree, because this is another straight line. This opposite here, okay, from here like this is 180. And this is 90. This is 25. So we are going to have where that arrow is pointing, the size of the angle there is going to be 180 minus 90 plus 25. That is 180 minus, this is 115, okay? And that is going to give us 65. 65. So that angle is 65. So the bearing I'm looking for now, the bearing of the harbor from both C is equals to 180 degrees plus 65 degrees. And that gives us 245 degrees, okay? So we enter that. Now, the next question says, show that angle CBH is 100 degrees. Angle CBH. Okay, this is C to B, C to B to H. So this is the angle we are referring to. We want to show that that angle there is 100 degrees. Of course, take note that this angle here is 55. This angle here is 25. And then the third angle here, if we add the three together, if we add 1, 2, 3, it will give us 180 degrees, some of interior angles of a triangle. So if we want to get that angle, we are going to say 180 minus 55 degrees plus 25 degrees, okay? So that is going to give us 180 degrees minus 80 degrees, and that gives us 100 degrees, okay? So that is the size of angle CBH. We have showed that it is 100 degrees. The BII says show that BH is 13.7 kilometers correct to 1 decimal place. BH. So let's look at that. That is BH is this line here from B here to H. So now we are going to use sine rule. Okay, we're going to use sine rule to get that. So we are going to take the side we are looking for, BH, all over is facing sine 25 degrees. Let's go back to that. Look at the side BH, okay, is facing this angle here, okay? It's facing that angle, 25. Look at that. It's facing 25, okay? And then we are going to look at which one is facing 32. That is this angle here, which we got as 100. So we are going to do 32 over sine 100 also. So this is 32 over sine 100 degrees. So make BH the subject. You will get 32 times sine 25 all over sine 100, okay? So this is going to give us, if you use your calculator to clear this, you're going to get 13.7325 and so on and so forth, okay? Writing this correct to 1 decimal place, we have BH is equals to 13.7 kilometers. So this is, we have showed this, we've shown this. So we proceed. The C part of this question says calculate the bearing of A from B. Calculate the bearing of A from B. Now, let's go back. The bearing of A from B. Okay, look at it. The bearing from B, I am going to negotiate the whole of this at this. The bearing of A from B. So I'm going to go this way. All right, that means I am going to take 90 here. I have 100 here, but I don't have theta. Okay, let me call that angle theta. So these three angles, if I add them together, it's going to give me the bearing of A from B. And for me to get theta, already I have this line here, 13.7. So I have this. The three sides are given. I'm going to use cosine rule to get the value of theta. Okay. So here, I'm going to apply and say cos theta is equals to 11 squared plus 13.7 squared minus 4. Okay, let's look at those side again. 13%, the other side is 14. Okay, minus 14 squared. So I have minus 14 squared. If you do not understand how to use cosine rule, I've made a video. Go to my channel and check video on trigonometry. I've explained how to apply cosine rule to find unknown angles in a triangle where the three sides are given, or where you have two sides and one included angle. You can check it out. Then I have 2 multiplying 11 and 13.7. So here cos theta will give me 112.69 all over 30 1.4, okay? Cos theta is going to give 0.37388 and so on. So theta will be the arc cos, okay, of this. Okay, so yeah, theta is going to be around 68 degrees, okay? So the bearing, the required bearing that we are looking for, required bearing is going to be 90 degrees, like I said before, plus 100 degrees, plus 68 degrees, okay? And that gives us 258 degrees. So we enter it 258 degrees, okay? We will proceed to the D part of this question number 6. Question 6D says at 1 p.m. boat 6 sails 32 kilometers directly to the harbor at a speed of 10 knots. Calculate the time when boat C arrives at the harbor. Give this time correct to the nearest minute. Take note of this, nearest minute. And 1 knot is 1.852 kilometers per hour. Time, as we know it, is distance over speed. Remember that speed is distance over time. If we make time the subject, it gives you distance over speed. Now, the distance here is 32 kilometers, okay? And the speed is 10 knots, but let's convert. We are told that 1 knot equals 1.852, okay? That means if you multiply both sides by 10, this is going to give us 10 times 1.852. Okay, this is 18.52. Okay, so this is 32 over 18.52, right? Now this is going to give us 1.727861, blah, 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 and some other factors, right? So that is 1.727861 hours, all right? Now that's going to give us 1 hour, okay? So how do we convert this decimal part to minutes, okay? This decimal part, how do we convert it to minutes? If you remove 1 hour, that means if you say 1.727861 minus 1, all right, you are going to get 0.727861, okay? So now multiply that by, this is also hour, okay? So convert it to minutes, multiplying by 60. So if you multiply this by 60, if you multiply 0.727861 hour by 60, okay? That gives us 43.67, gives us 43.67 and so on and so forth. So this is 1 hour 43.67 minutes, okay? So this is like 1 hour 44 minutes. Now, if the boat were at 1 p.m., the boat sails 32 kilometers, right? At 1 p.m. So add 1 hour 44 minutes to 1 p.m. That will give us Okay, if you add 1 p.m. plus 1 hour, 44 minutes, that will bring us to 2 p.m. That is 2.44 p.m. That is going to bring us to 2.44 p.m. So this is 2.44 p.m. Okay, so we'll write it here, 2.44 p.m. All right, so that's it. Hope this is clear. Now here we are asked to calculate the distance of the boat, the distance of boat C to the harbor when boat C is at the shortest distance from lighthouse B. Again, calculate the distance of boat C to the harbor when boat C is at the shortest distance from lighthouse B. Let's go back to that diagram. If boat C, all right, if it is at the shortest distance, let's clean up some things, yeah? Okay. So when the boat C is traveling down, okay, take note, it's traveling down to the harbor, okay? It's coming down to the harbor, all right? So it's following this line. So at some point, boat C is going to be around here, okay? Now, when it will be the shortest distance to the harbor is when the distance here is at 90 degrees to the path that the boat is following towards the harbor, okay? When it is 90 here, all right? Because if you look at that question again, look at that question. The question says, calculate the distance boat C, the distance of boat C to the harbor when boat C is at the shortest distance from lighthouse B, from lighthouse. So that's why we are picking it from here. Shortest distance from lighthouse to boat C. Shortest distance will be a line perpendicular to this road taking us from C to the lighthouse, okay, to the harbor. So the shortest distance, so we are looking at BC. You know, remember that we can also have it here, okay? This is another, it can be here, okay? It can be here, okay? All right, it can also be here. Okay? But each of these dotted lines, they are longer compared to this red line going from B to C, right? Compared to this. All the other dotted lines are longer. So the shortest one, we have to make 90 degrees to this line CH. The shortest possible distance from B to C must make 90 degrees to the path CH. Okay, so remember that what we are now looking for here, go back to the question, what we are looking for is the distance of the boat. We are asked to calculate the distance of boat C to the harbor. Okay, so when it is at shortest distance from the lighthouse. So we are looking for this distance from point C to point H. Remember also that this is 13.7 and this is 55. So let's take that now. Let's take that triangle. This right angle triangle, yeah. This is 90, this is where C is. This is the lighthouse. This is the harbor, okay? And this is 13.7. This is 55, okay? So I'm looking for HC, okay? Which is, this is the opposite, and this is the adjacent. So we use cosine here. Cos 55 degrees is HC all over the hypotenuse, 13.7. HC is 13.7 times cos 55. Okay, so HC is 7.85, 7.8579, so on and so forth. So writing this out to 3SF, 3 significant figure, will give us 7.86 kilometers. So that will be the distance of both C to the harbor when both C is at the shortest distance from the lighthouse B. So we'll have a short break and we'll be right back. Welcome back. This is Math Minders Academy, your one-on channel for mastering mathematics concept with ease. If you're just joining us, we urge you to hit the notification bell so that each time we produce a video, you'll be among the first to get it. And if you have not subscribed, go forward and subscribe to our channel so you become part of us and you continue to enjoy our wonderful tutorial videos. Don't forget to make a comment on the comment section. Tell us how you feel we can improve our tutorial videos to help you and to help others that will be preparing for examination. Let's proceed to question number 7. Question 7, the diagram shows a bus in the shape of a cuboid. The bus is open at the top. Work out the surface area of the inside of the open bus. So now what it means is we are going to add this one, this back here, 2, and this front. They all look alike. This one here, let's take the area of this. The area of this and the area of this, they are the same, okay? So it's going to be 2 times, this is 40, and the length is 70, plus, okay, let's pick another one. This one here, this shape here, like this rectangle here, the area of this and the area of this one here, this one here, they are the same, okay? So we'll double this area. We'll double this area. So that will give us 2 times 40, that's 40 by 30, plus, so we take this base here, this rectangle here, we find the area of this. That is 70 by 30, okay? So now, if we multiply out here, this is going to give us 2 times 2,800 plus 2 times 1,200 plus 2,100, okay? So this is going to give us 5,600 plus 2,400 plus 2,100. So this is going to, we add this together, we are going to get 10,100 centimeters, okay? Centimeter, square, that's going to give us, so here we write 10,100, okay? That gives us the area that we need. I say cylinders with height 20 centimeter and diameter 15 centimeter are placed in the box. Work out the maximum number of these cylinders that can completely fit inside the box. Now, this is where students need to be careful. It's an arrangement. We don't need to do volume of cuboid minus volume of cylinder. It doesn't work here. Now, let's clean up all of this. We are going to clean up all of this. We want to arrange cylinders here, okay? Now, take note of the dimensions of the cylinder. The cylinder is having height 20 centimeter and the diameter is 15. So this is the cylinder we want to put in. The cylinder, let's get a picture of the cylinder, okay? The height here is 20. The diameter here is 15, okay? Now, along this part, this is 30. This is 30 here. So we can have two cylinders here arranged perfectly. Why? Because the diameter is 15, 15. So we can get the two cylinders here. Okay, let's put it here. So this arrangement can come like this. And then we can have another. Okay. Okay, so that if we take 15, 15, so we can comfortably have this, okay? Now, this is 70, okay? And the cylinder that can enter here, because the diameter here is 15, let me use so that we will understand this. The diameter here is 15. Okay, one cylinder will enter. Another cylinder of diameter 15 will enter, making 30. Another one here of diameter 15 will come in, making 45. Another one here will come in, making 60, okay? We won't be able to have any other cylinder here because this is remaining 10, okay? It can't contain any other one. And remember, going this way, we have another one like this because coming like this, we'll have 15 this way, 15, 15, that's 30. So now, along the base, we can only have 1, 2, 3, 4, 5, 6, 7, 8. 8 cylinders arranged, okay? Now, the height of the first cylinder is going to be 20. So this can also take another cylinder, another layer of cylinder. So the first layer here is going to be 8. The second layer, another 8, okay? The first layer, okay, if we have something like this, so we are going to have the second layer like this. We have again, okay? And then we'll have them this way, okay? So that this will come down, okay? I hope you can picture what I mean. So we now have here, so this what we are going to have here is actually the first and the second layer. On the first layer, we are going to have 8 cylinders. 8 cylinders. The second layer, we have 8 cylinders, okay? So altogether, we are going to have 16 cylinders total. Total is 16 cylinders. So if we arrange, it's just like you have a line of 70 centimeters and you have to cut it 15, 15. The maximum you can get is 4. So if this is 15, one cylinder, another cylinder, another cylinder, another cylinder, we can't have a cylinder here. So along here, we can have only 4 cylinders. And going this way, where this line is 30, we can only have 2 cylinders, 15, 15. So we have 4 by 2, 2 layers of 4 by 2. That is 16 cylinders. The first layer will contain 8 cylinders. Of course, the second layer will contain another 8 cylinders because we have the height of this cuboid to be 40 and the height of cylinder to be 20. So 2 cylinders, one on top of another, can actually come here. All right. So the first layer will contain 8 cylinders. The second layer, another 8 cylinders, making 16 cylinders. Okay. So here we say first layer contains 4 by 2, okay, cylinders, which is 8 cylinders. Second layer contains also 4 by 2 cylinders, okay, which is also 8 cylinders. Okay, total now will give us 16 cylinders. Of course, the construction we make there is also part of the explanation. The construction we make on the cuboid shows this explanation. So the maximum we can get here is 16 cylinders. Hope that is clear. We move on to the B question here. The B says a solid bronze cone has a mass of 750 grams. The density of the bronze is 8.9 grams per cubic centimeter. The radius of cone to height of cone is 1:3. Show that the radius of the cone is 2.99 centimeters correct to 3 significant figures. We have to note that density equals mass divided by volume. And then we are giving formula for volume of a cone here. Okay. So here we have 1 cubic centimeter is the density of the bronze is this per cubic centimeter. So this is the same thing as 8.9 grams, okay? Now, we don't know how many cubic centimeter that will be equivalent to 750 grams, okay? So we are going to find that. So when we make S the subject here under cross multiplication, we are going to have, this is 8.9x equals 750. So S is going to be 750 over 8.9. Okay, 750 over 8.9. And this will give us 84.269, okay? Okay, since this is the volume of the bronze, whose mass is 750 grams, okay? Now, we are told here that radius ratio height is 1:3, all right? And so we can have R over H is 1/3. Since here we want to show that the radius is 2.99, So we are going to create a relationship here. Okay, that means the height, if we cross multiply, is 3 times the radius, okay? Now, if we now take the volume, if we look at this and we want to find the radius. So we have seen this volume now is, we can use this formula. We are saying 1/3 by r squared h is the volume here, is the volume of the bronze. Okay. So what we have here is 1/3 times 3.142 times this is r squared. Then this is 3r here, because we say h is equivalent to 3r. And this will give us 84.269. Okay. So if we multiply out here, let's see what this will give to us. So this side is going to give us 3.142 r cubed equals 84.269. Okay, making r cubed the subject, we have 84.269 all over 3.142. So r is the cube root of the value we get here when we divide 84.269 by 3.142. We get 26.82. So the cube root of 26.82 to 3 significant figure is 2. Okay, first we have 2.9933 and some other numbers, and this to 3 significant figure is actually going to be 2.99, which is what we are asked to show. PII said we should calculate the total surface area of the cone. Okay, so if this is the cone, okay, this is the cone, and then we have this. Okay, so we have the height down here, and we have this. Okay, so this is the slant height. Okay, we have this. Okay, so if we bring this out, this is the radius, this is the slant height, and this is the height. Okay. Okay, so now if we look at the radius, we've seen that this is 2.99. The height of the cone. How do we get the height of the cone? Remember that h is 3r, so which is 3 times 2.99. So the height is going to be 8.97, okay? So this is 8.97. So we need the slant height. We'll use Pythagoras to get the slant height. So that will give us 8.97 squared plus 2.99 squared, okay? So slant height is going to give us square root of, if we do this, we are going to have 89.401. Okay, so this gives us 89.401 here. So, and this square root, we find the square root is 9.455. Okay, so that is the slant height. Now, the total surface area. The total surface area of the cone, which is going to be the curved surface area plus the area of the base, the area of the circular base. So this is going to give us pi r into L plus R, okay? So this is going to give us 3.142 times 2.99 into 9.455 plus 2.99, okay? So this total surface area will give us, if we multiply out and add, this is going to give us, that is, everything here coming up here is going to give us 116.915, okay? Which to three significant figure is going to give us 117 square centimeters. So we enter it 117 here. So we proceed to question number 8. On the axis, sketch the graph of y equals s squared plus 7s minus 18. On your sketch, write the values where the graph meets the x-axis and the y-axis. So there are three things we are going to do here. Three things. We are going to get the roots. Okay. We are going to get the turning point. And we are going to get the y-intercept for us to be able to sketch this, okay? So now, we are given, let's solve this. X squared plus 7x minus 18 equals 0, okay? Now, when we look at minus 18, and we pick two factors, okay? We want the product to be negative. We want the product of 9 and 2 to give us minus 18, and the sum of these two numbers to give us 7. So this will be minus 2 here. 9 times minus 2 is minus 18, and 9 plus minus 2 is 7. So we are going to have s squared plus 9s minus 2x minus 18 equals 0. So we want to factorize. We have x into x plus 9 minus 2 into x plus 9 equals 18 equals 0. Equals 0. So here we have x plus 9, x minus 2 equals 0. So solving this, x plus 9 equals 0 or x minus 2 equals 0. So here x equals minus 9 or 2, right? So we have minus 9 and we have 2. Okay. So we've been able to get this. Now for turning points, let's mark off this, okay? For turning points, we are going to do this. Turning point, the s value is minus b all over 2a, right? A is the coefficient of s squared, which is 1. B is the coefficient of s, which is 7. C is the constant, which is minus 18. So S here is minus 7 all over 2 times 1, which is minus 7 over 2. That is minus 3.5, okay? So it gives us minus 3.5. Okay, let's continue around here. So now we are going to get the value of y. Substitute. We substitute there. That means y is going to be minus 3.5 squared plus 7 times 3.5 minus 18. Okay, so y is going to give us, if we work on this, it's going to give us minus 30.25. Okay, so the turning point will occur where S is minus 3.5, okay, and Y is minus 30.5. So it's, let's say around here, okay. Now the constant, if we look at this equation here, the y-intercept is the constant. So the y-intercept here is minus 18. So we have the turning point, we have the y-intercept. So y-intercept is minus 18. So let's see here as minus 18. Okay. And let's take here to be, all right, minus 30.25. So this is minus 30.25. Okay. So we can sketch the curve now. So the curve is going to be a parabola in the shape of letter U, because the coefficient of S squared is positive. So it's going to have this shape here. So it's going to come this way, hit this place, then turn here, touch this place, and then that is the curve. So that's the required curve that we are asked to sketch. So here we are asked to find the derivative of y equals s squared minus 3s minus 28. That is dy ds. Equals, now we bring down these two, reduce the power of s by 1 minus, so we have 3x, this is 1 minus 1. And if we differentiate a constant, you have 0, okay? If we differentiate that minus 28, we have 0. So this gives us 2x minus 3. Okay, this is actually 3x raised to power 0, which is 1. So here gives us dy ds to be 2x minus 3. We are going to build a video to discuss derivative of quadratic functions, so that you understand step by step required to differentiate a function. So this is going to give us 2x minus 3. Here, this second part, we are asked to find the coordinates of the turning point of y equals s squared minus 3s minus 28. Yeah, we need to find the coordinates of the turning point. Now, we know that at turning point, the s value is going to be minus b all over 2a. And here, a is the coefficient of s squared, which is 1, and b is the coefficient of s, which is minus 3. So the s value of the turning point will be minus 3 all over 2 times 1. That's 3 all over 2. And we have 1.5, okay? So the y value of the turning point, we substitute 1.5 into this equation. Okay. And that is going to give us minus 30.25, okay? So the turning point this is the coordinate of the turning point, 1.5, comma, minus 30.25. So we enter it here, 1.5. This is minus 30.25. Now, question C, we are told that the line y equals 5 minus 2s intersect the graph of y equals s squared minus 3s minus 28 at the point P and point Q. Find the coordinates of P and Q. And we have to show all our workings and give our answer to 2 decimal places. So if this line intersects with this curve, then it means that s squared minus 3x minus 28 equals 5 minus 2x. This becomes s squared minus 3x of collect like terms plus 2x minus 28 minus 5 equals 0. So we have x squared minus x minus 33 equals 0. Okay. Now, since we are going to round this up to 2 decimal places, it means that the answer to this, the root of this quadratic will float. So we are going to use the formula x equals minus b plus or minus square root b squared minus 4ac all over 2a. So here a is the coefficient of x squared, which is 1. B is the coefficient of s, which is minus 1. And c is the constant, which is minus 33. So when we put it here, we have x equals minus 1 plus or minus square root minus 1 squared minus 4ac. This is ac here, all over 2a. So s becomes 1 plus or minus square root 133 all over 2. So here s is 1 plus or minus square root of 133, we have 11.532 all over 2. So we proceed. So here x equals 1 plus 11.532 over 2, or 1 minus 11.532 over 2. Okay, here s becomes 6.266 or minus 5.266. Okay, so to 2 decimal places here, s is going to be 6.27, approximately equal to this, or approximately equal to minus 5.27. Okay, so that's that. Okay, so but we are not done with this. Those are 2 values of s. We are going to use them to provide 2 values of y. So we'll go here and said, okay, we want to produce the 2 values of y that correspond with this. We now say when x equals 6.27, y is going to be y, because look at the value here, y is 5 minus 2s. So it's going to be 5 minus 2 times 6.27. So y will become minus 7.54. Okay, so we now have this coordinate 6.27 comma minus 7.54. Okay, we'll go again. When x equals minus 5.27, y becomes 5 minus 2 times minus 5.27. So y becomes 15.54. So this is the coordinate for that, minus 5.27, comma, 15.54. All right. So it is these values that we enter here. We have 6.27 and minus 7.54. We have minus 5.27 and 15.54. Okay. So we move on to question number 9. Before we take question number 9, we'll go on a short break. Welcome back. In this video, we are showing the best method for solving IGCSE problems. Don't forget to subscribe if you have not done so. Hit the notification bell so you will never miss out on any of our new videos that we release. And you also not miss out on our examination tips and solutions here on Math Minders Academy. Let's proceed to question number 9. Question number 9, we are given these functions, f function, g function, and h function. So here we want to find f of 3. So this is going to be 4 times 3. So that means anywhere we have s, we are going to replace with 3, then plus 1. And this will give us 12 plus 1, which is 13. So here, this is, since we know what f of 3 is, so since f of 3 is 13, this is g of 13. So we go to the g function, and then we are going to replace s with 13. So this 6 minus 26. So this is minus 20. We are asked to find g inverse of s. So let g inverse of s be p. Okay, that means x is going to be g of p. Okay, which is, we'll go to g function and put p. That is 6 minus 2p, right? So that's what s will be. So let's make p the subject. It means that x plus 2p equals 6. 2p equals 6 minus x. So p is 6 minus x all over 2. And this will be the inverse. So it means that the g inverse of x is 6 minus x all over 2. Okay, so we've been able to find a value for that. We proceed to the C part of this question. So here we are asked to find s when f of s equals g of s, okay? So remember that f of x equals 4s plus 1. And g of 2x minus 7 equals Okay, we notice of course we know that g of x is equals 6 minus 2x. So this is going to give us 6 minus 2. So we replace s with 2x minus 7. And then this is going to give us 6 minus 4x minus 2 times minus 7 is plus 14. So that is going to give us 20 minus 4x. So we want to now equate these two values here, f of s and g of 2s minus 7. So that means 4x plus 1 equals 20 minus 4x. So when collect like times 4x plus 4x equals 20 minus 1. 8x equals 19. And so x itself is going to be 19. If you divide both sides by 8, 19 over 8. So s is going to be 2.375. 2.375. So enter it on the answer line. S is 2.375. Here we want to find the value of h of 2. We know that h of x is defined as 3 raised to the power x minus 2 if we check the very beginning of this question. So now we can calculate h of 2, and that is going to give us 3 raised to the power 2 minus 2. That's 3 raised to the power 0, and this is 1. So h, if we take h of 2, that will give us h of 1. That will give us 3 raised to power 1 minus 2. And that gives us 3 raised to power minus 1. That's 1 over 3. So we enter 1 over 3 for that. And finally, 9e, we are asked to find x when h of s is 10, h inverse of s is 10. So here, if h inverse of x is 10, it means therefore that s is h of 10, okay, which is going to give us 3 raised to power 10 minus 2. That gives us 3 raised to power 8. 3 raised to power 8 is 6,561. That is 561. Okay. And this is how we come to the end of this tutorial video. We urge you to subscribe if you have not done so to our channel, so that you become one of our community members, and hit the notification bell so that each time we produce a new video, you'll be among the first to receive it. Comment on this video, share it, and like it so that the YouTube algorithm will take this video to other students that will be in need of it. We will be producing another video for paper 2-1. So be looking forward to having you around when we will be discussing step-by-step solution to questions in paper 2-1. We'll see you in our next class. This is Math Minders Academy saying goodbye for now.
In the midnight glow where the stars align, we lose ourselves in the rhythm divine. Underneath the sky painted with dreams, we're chasing the echoes of silent screams. Caught in the spell of the cosmic night, where fantasies bloom.